The square root would be 3, and since the 9 is underneath the y, we'll put a y next to it, so this will be 3 units in the y direction. And last part for the foci. The equation is a squared minus b squared equals c squared, where a squared and b squared are the two numbers underneath the fraction. So 16 minus 9 would be 7. That's equal to b squared though, so the foci distance would be the square root of that, or square root of 7. To graph from here, we can draw the xy axis. The center again would be at 3, negative 2. The major axis is 4 units in the x direction. So in the x direction, which would be left and right, we'll go 4 units each way. So 4 units to the right and 4 units to the left. For the minor axis, which would be shorter, in the y direction will only be 3 units. So we'll go 3 units up and 3 units down. So it's almost like a circle, except you have 2 different directions. We have 4 going left and right, and 3 going up and down. If we connect these, that will get us the ellipse shape, which is an oval shape. And the last part, we want the foci distance. The foci will be 2 points inside the ellipse. From the center, it goes in the major axis direction. So we'll go in the x direction, and it'll go square root of 7, which is a little bit less than 3. So we'll have 2 points inside the ellipse for the 2 foci points. Second question and last question for the section is y squared over 10 plus x squared over 5 equals 1. And again, this is in standard form for an ellipse. If we have x and y squared, both in fraction form, and it's equal to 1. First part for an ellipse, we'll find the center. The x value again would come from the x. If there's no number next to it, the center would be 0. And the same thing for y. There's no number next to it, so the center would be 0, 0. The major axis, again, is the bigger number underneath the fraction, which would be 10. The major axis would be the square root of 10, which would be just over 3. And again, this comes from the fraction with the y, so this time the major axis will be in the y direction. The minor axis is the smaller number, which would be 5. And again, underneath the x, so this will go in the x direction, and we always take the square root to find the minor and major axis. Last part for the foci. We'll subtract again a squared and b squared, the 2 numbers underneath the fractions, which would be 5. And to solve for b again, we'll take the square root. So the foci distance would be the square root of 5, which would be just over 2. To graph this, we can draw the xy axis. The center is 0, 0 in the middle. The major axis in the y direction, which will go vertically, up and down. Square root of 10 is just over 3. So we'll go just past 3 up, and just past negative 3 down. Square root of 5 is just over 2. So we'll go a little over 2 to the right, and a little over 2 to the left. And again, you can connect them to make the oval shape. It's a oval because the distances are different in the x and y direction. The foci again always goes in the major axis direction. So in the y direction, the two foci would be square root of 5, or about 2 spots up, and just over 2 spots down. And that would be the graph for the ellipse. Title of the last section is Graph a Hyperbola. First equation is x squared over 81 minus y squared over 49 equals 1. Again, this is in standard form for a hyperbola. If you have x squared and y squared on the same side, both a fraction, and instead of a plus sign you have a minus sign, and it's always equal to 1. First step, we want to find the center. The center again would be the opposite numbers next to x and y. Neither have numbers, so the center would be 0, 0. For a, it'll be the number underneath the x, which is 81. Taking the square root of 81, that would be 9, and that would be 9 in the x direction. Same thing for the number underneath y. We'll take the square root, which would be 7, and we'll put 7 units in the y direction. From here we can graph. The center would be in the middle. 9 units in the x direction from the center. We'll go 9 units to the left and also 9 units to the right. Also for the y value, we'll go 7 units. That'll be 7 units up and 7 units down. Instead of connecting these to make a circle or oval shape, we'll connect these to make a box. We'll basically go straight off to the left, then straight down through each point, and then straight to the right, and straight up, and connect it to make a box. So it goes through each of the 4 points that we drew. To make the diagonals, we'll go from one corner of the box to the other, and we'll go through the center, and we'll pass through the corners of the box and extend it out a little bit so we have the diagonals outside the box. And we'll do that in each direction. From here, we can draw the hyperbola, which is basically 2 parabolas. The parabolas either open on the x-axis, which would be horizontally, or they open vertically on the y-axis. To determine which one, look back at the original equation. We have x squared minus y squared. Whichever variable goes first, that's the direction it would go. So the x-axis would have the 2 parabolas, and they go parallel to all the dashed lines. They'll connect to the point that we had at the end of the box, and continue to go parallel next to the other dashed lines. And this will be one parabola shape on the left side, then we'll have another one on the right side. And again, it connects to the point on the right, goes parallel and gets close to, but does not cross the dashed lines, which are like asymptotes. And you have the two parabola shapes, which together are the hyperbolas. The last part's the foci distance. For the foci distance, we'll have 2 points inside each of these parabolas. To find the distance, we'll add the two numbers we had before, a squared plus b squared. So 81 plus 49, that would be 130. Taking the square root of that would be just over 11. So if we go back to our center was 9 spots out. If we go 2 more spots and a little bit past, that's where the first foci would be. And the same thing on the right side. And that would finish the graph for the hyperbola. Second graph and last equation for the section is y minus 2 squared divided by 4 minus x plus 1 squared divided by 9 equals 1. And again, this is in standard form. We have x and y squared on the same side, both in fraction form, with a minus sign between them, and it's equal to 1. To find the center, again, the opposite of the x value would be negative 1, and the opposite of the y value would be positive 2. For the two numbers, it doesn't matter which order you do them in. You can do the first number, which would be 4. Always take the square root, which would be 2. And again, this is underneath the y fraction, so this would be 2 units in the y direction. The second number, 9, the square root would be 3. This is on the x fraction, so that's 3 units in the x direction. If you want to do the foci before your graph, 4 plus 9 would be 13. And the square root of 13 would be a little over 3 and less than 4. And again, those will go inside the parabola shapes after we graph. To graph the hyperbola, we can draw the xy axis. The center again is negative 1, positive 2. We're going to go 2 units in the y direction, so that would be 2 units up and 2 units down. We'll go 3 units in the x direction from the center, so 3 units to the right and 3 units to the left. Again, for a hyperbola, instead of connecting the points to make a circular shape, we will connect them to make a dashed box, which will go straight through all 4 points to make a box that we can draw the diagonals through and then draw the hyperbola. After you draw the box, we'll draw the diagonals that go through the corners and through the center and extend out past the box on both sides. To draw the parabola from here, or hyperbola from here, we can decide which direction it goes. Looking at the fraction, or the original equation, we have y minus x, so the hyperbola will go in the y direction, which means the hyperbolas will open up and down vertically. And again, you connect it to the point on the box. It doesn't go inside the box, it doesn't cross the dashed lines, but it'll continue on as a parabola shape. Same thing on the bottom, it'll connect to that point on the box and go parallel and right next to all the dashed lines. For the foci, square root of 13, it's a little bit more than 3. In the y direction, we went 2 spots up, so the foci would be just above 3 spots in each direction. And that would be the graph for the hyperbola. Title of the first section is Determine. Type of graph. Without factoring. First equation is y squared minus 2x squared minus 4x minus 4y minus 4 equals 0. This equation is not in standard form for any of the graphs, but without factoring it or without solving it, we can determine the type of graph. We want to look at the variables that are squared. We have y squared and negative 2x squared. So both variables are squared, so it's not a parabola. We have a positive y squared and a negative x squared. There's one graph that has one variable positive and one variable negative, and that graph would be a hyperbola. So by looking at the equation, we can determine that this graph would be a hyperbola shape. Second equation we'll look at, and last equation for the section. 4x squared plus 4y squared plus 20x minus 12y plus 30 equals 0. And again, by looking at the equation, we can tell what type of graph this would be. Looking just at the variables that are squared, we have 4x squared and 4y squared. Both of them are the same signs and same coefficients. If both have the same coefficients and are both positive, this graph would be a circle. Title of the next section is Write an Equation. In standard form. One definition for the section is complete the square. To complete the square, we will add the fraction b over 2 squared to both sides. This will enable us to factor by completing the square and get the equation in standard form. First equation we'll look at is y equals x squared plus 6x plus 1. By looking at the equation, we can tell what shape it is. It has a single variable squared, so a single variable squared means this will be a parabola shape. This is good to know, so we know our final answer should be in standard form for a parabola. To complete the square, we'll bring down the x squared plus 6x, and to factor this, we'll have to add a number to make it a perfect square trinomial that we can factor, and that number will be b over 2 squared. The plus 1 we have above will come down, and the y will come down also. To find b over 2 squared, we'll take the value b, divide by 2, which would be 3, and square that, which would be 9. So we'll add 9, so this becomes a factorable trinomial. Since we add 9 to one side though, we'll have to add 9 to the other side. Bringing down the question, we have 9 plus y equals factoring x squared plus 6x plus 9. That would factor to x plus 3 and x plus 3, or we can write it as x plus 3 squared. And the plus 1 comes down. Last step to put this in standard form for a parabola is to get y by itself. So we can subtract 9 on both sides. And our final answer would be y equals x plus 3 squared minus 8. And that would be the equation in standard form for the parabola. Second question, and last question for this section, is x squared plus 4y squared plus 2x minus 24y plus 33 equals 0. To factor this one again, we want to complete the square. X squared would come down, and we want to bring the x's next to it so we can factor the x's together. And when we complete the square, we'll add a number in just a minute so we can factor that. The 4y squared will come down, and we'll put the minus 24 after that, 24y. And again, we'll add a number to the y value so we can factor that in just a minute. For the plus 33, what we can do is we can move that to the other side by subtracting 33. So it'll be equal to negative 33. When we're factoring both x and y, any other number we want on the other side. To factor this, we can complete the square on the x's. b divided by 2, or 2 divided by 2 would be 1. Squaring that would be a positive 1. So we'd have x squared plus 2x plus 1. But since we added 1 to the left side, we'll have to add 1 to the right side also. Factoring the x's, x squared plus 2x plus 1. That would factor to x plus 1 squared. Before we factor the y values, one other step in completing the square is the variable squared has to have a single 1 as a coefficient. Right now it has a positive 4. So what we can do is actually factor out a positive 4 from that y squared. And we can also factor out a 4 from the negative 24, so that would be negative 6y. And again, we'll still have that number that we'll find in just a minute. And it's equal to negative 33 plus 1 would be negative 32. If we complete the square on the y value, negative 6 divided by 2 would be negative 3, squaring that would be 9. So we're adding 9 to the y so we can factor. There's a 4 outside the parentheses though, so instead of adding 9, we're actually adding 36. So if we add 36 to one side, we'll add 36 to the other side. Completing the question, x plus 1 squared would come down. The 4 would also come down. Y squared minus 6y plus 9, we can factor. That would factor to y minus 3 squared equals. And negative 32 plus 36 would be positive 4. Looking at the equation, we can tell what shape it might be. X squared and y squared would be positive. So what we want to do is have the equation equal to 1. To make this equal to 1, we can divide by 4, which would also cancel out the 4 in front of the parentheses. So our final answer, we'll have x plus 1 squared over 4, plus these 4's would cancel, so we'll have y minus 3 squared and equals 1. Looking at this equation, this would be the standard form for an ellipse. So this would be the answer to the factored equation, which would be a standard form for an ellipse. Title of the first section is write each equation in standard form and graph. First equation for this section is 6x squared plus 6y squared equals 162. It's a good idea to look at each equation and determine what type of graph it is so we know what the standard form should be. In this question we have both variables squared and they both have the same positive 6 coefficient. So this graph would be a circle graph. To make this in standard form, we have to get rid of the coefficient 6. And what we can do is divide by 6 on both sides. And that'll cancel out the coefficients. So we'll be left with x squared plus y squared. And 162 divided by 6 would be 27. And by dividing by 6, now this is in the standard form for a circle. Second part of the question is to graph. For a circle, we need the center. The center again would be the numbers next to the x and the y. There's no numbers, so the center would be 0, 0. And also for a circle, we need the radius. The radius is the numbers equal to 27, but we'll take the square root of 27. To graph this question, we can draw the xy axis. The center is 0, 0. The radius is the square root of 27, which would be a little bit more than 5. So we'll go 5 spots up and 5 spots to the right. and 5 spots down, and 5 spots to the left.